Hello everyone. I'd like to talk to you a little bit today about some of the major concepts that you saw in the notes and make sure you kind of understand what's going on. And the main thing I want to talk about is bond polarity. But before I do that, let me just talk a little bit about life in general. As we get a little older, we realize that life is not so black and white. There aren't things that are necessarily purely good, purely evil. Many things we need to evaluate on a case-by-case basis and look at the larger context. And it turns out bonds are like this as well. So we started off talking about ionic bonds, where we would have a sodium atom which would give an electron to a chlorine atom, a transferring of electrons, and then Na and Cl would form a bond where sodium is positive and chlorine is negative. And then we considered a different type of bond, let's say a chlorine-chlorine bond, where in this case we've got this line here, which represents a pair of electrons, and that's two electrons that are being shared by both chlorines, shared equally. And that's a covalent bond. Now, as it turns out, there's a third type of bond. Take hydrogen, for example. If it's going to form a bond with chlorine, hydrogen brings one electron to the party. Chlorine brings 7 valence electrons. They're going to share 2 electrons there just like that. Now, as it turns out, chlorine is sort of like that mean older brother or older sister who wouldn't let you play with the toys. It will share electrons, but it's not a very good sharer. It's kind of a hog. So these 2 electrons that are being shared, they're not being shared equally. And they will spend much more time with the chlorine than they'll spend with the hydrogen. So what happens, since electrons are negative and chlorine is sort of hogging the electrons spend more time with chlorine. Chlorine develops what we call a partially negative charge, which gets this funny little symbol and a negative sign. And hydrogen develops what's called a partially positive charge, so this funny little symbol and then a positive sign. Another way to indicate that same thing is to draw a little arrow like this. And it's no coincidence that this side of the arrow looks a bit like a plus sign. We draw an arrow pointing towards chlorine. It's always going to point towards the more electronegative element. Chlorine is one of the more electronegative elements. So this side ends up being a partially positive, looks like a little plus. That side ends up being partially negative. So there is a way to tell whether bonds are ionic, polar covalent, or covalent, and it mainly revolves around electronegativity values. So what you're going to want to find is you're going to want to find this section in your workbook. We've looked in here before, and you want to find it's towards, I think it actually is the very first page, which is this page. It looks like this. Conversion factors on the top. But our concern right now is going to be this periodic table of electronegativities. So why don't we go ahead and pause the video just a moment and make sure that everyone has that. Okay, so hopefully I have that at this point. What we're going to be doing is looking for this page. It says polar practice at the top. And I'm going to leave this first question for you. What does it mean to say that a bond is polar? And we're going to look at these 3 examples. Now, I've worked out 3 examples here in advance, but let me show you exactly how I did that. We're going to label each of the following bonds as ionic, polar covalent, or non-polar covalent. Notice NaCl. Now, it shouldn't come as a surprise to us here that NaCl is an ionic bond, because sodium's a metal, chlorine's a nonmetal, and that's what we've learned about. That makes ionic bonds. But if we wanted to confirm that in a different way, what we could do is we could look at our periodic table of electronegativities. We could notice sodium's electronegativity, which is 0.9. We could notice chlorine's electronegativity value, which is 3. And we could subtract those 2 values. Now, we're always just going to do the biggest number minus the smallest number. We're just always going to do it that way, so we always end up with a positive number. And once we subtract those 2 things, we're going to reference this right here. So I went ahead and did that. Chlorine's electronegativity minus sodium's electronegativity, which is 2.1. And if we reference our page here, 2.1 fits firmly in the ionic category. So indeed, Na and Cl is an ionic bond. And again, that shouldn't be a big surprise. But what about a bond between nitrogen and oxygen? Look up their 2 values. Oxygen is 3.5, nitrogen is 3. Always just do the biggest number minus the smallest number, so you end up with a positive value. I've done that here, 0.5. Reference our table again, 0.5 fits in the polar covalent category, so that bond between N and O is indeed a polar covalent bond, as I've indicated here. Now, what about a fluorine-fluorine bond? Well, fluorine is in fact the most electronegative element, as we perhaps recall when we studied electronegativity. Its electronegativity value is 4. So there's 2 fluorines, so it's going to be 4 minus 4, which of course is 0. And that would always be the case. Of course, we'd always get 0 for any diatomic element, or any time the same atom is bound with another atom, the same element. They're going to have the same electronegativity. Of course, it'll always be 0. So that's completely nonpolar covalent. And I'll let you guys finish the rest of those. Moving down to the bottom section here, it says for each set of bonds, rank them in order from most polar to least polar. So remember, bonding is a continuum from pure covalent, where you're totally sharing electrons, to ionic, where you're transferring electrons. And we can have everything in between. So we're going to rank these, and since we're ranking them from most polar to least polar, what we're going to do is we're going to subtract the values we see. So find each of these on the electronegativity table, subtract their values, and we would rank them from the largest difference when we subtract them, that would be the most polar, to the smallest difference, that would be the least polar. And that's what we'll do for A through E here, rank them from the largest difference to smallest difference. So that's it for the first part and the first video. We'll pause the video for a while, give you a chance to work on this for a while, and then we will talk about something else.